Show that if h is positive, applying Newton's method to the piecewise function, f of x equals the square root of x for x greater than or equal to 0, and the square root of negative x for x less than 0, leads to x sub 1 equals negative h if x sub 0 is h, and to x sub 1 equals h if x sub 0 equals negative h. First, Newton's method states that x sub n plus 1 equals x sub n minus f of x sub n over f prime of x sub n. We have f of x. We need f prime of x. F prime of x is still a piecewise function. The derivative of the square root of x is 1 over 2 root x for x greater than or equal to 0. The derivative of the square root of negative x is 1 over 2 root the negative x as an input still times the derivative of the inside function, which is negative 1. So this is negative 1 over 2 root negative x for x less than 0. If we start with x sub 0 equals h, then x sub 1 equals h minus f of h over f prime of h using the Newton's method. Since h is positive, we will use the p's for x greater than or equal to 0 for f of h. The same with f prime of h. F of h, where h is positive, is the square root of h over f prime of h, where h is positive, it is 1 over 2 root h. This simplifying to h minus the square root of h times 2 root h over 1. This is h minus 2, the square root of h times the square root of h is h. H minus 2h is negative h. So if we start with x sub 0 equals h positive, we end up with a x sub 1 negative. Now, if we start with x sub 0 equals negative h, which is a negative number, x sub 0 equals negative h, then x sub 1 equals x sub 0 negative h minus f of x sub 0, where x sub 0 is negative h over f prime of x sub 0 negative h. But this time, since negative h is a negative number where h is positive, we have negative h minus. We would use the piece for the negative, the second piece. F of negative h is the square root of negative x, but x is now negative h. For f prime of negative h, we would use negative 1 over 2 root negative, but the input is negative h. Simplifying this, we have negative h minus the square root of h over negative 1 over 2 root h, which is negative h minus root h times 2 root h over negative 1. This is negative h plus 2 root h times root h is h, and it is plus because a negative times a negative 1. Negative h plus 2h is positive h. If we start with negative h, we end up with h. Graphically, the graph of the square root of x is on the right hand side, and the graph of the square root of negative x is the square root function on the left hand side, but it is symmetric about the y-axis with respect to the graph of the square root of x. If we start with h positive, for example, a point right here between 0 and 1, we will see that the tangent line intersects the graph on the other side, and if this is h, then the other side is negative h. And the same thing, if we start with the negative h, which is on the left hand side, then the tangent line would intersect the graph on the other side, positive h. The consequence is that using Newton's methods, regardless whether we start with h or negative h, we would go back and forth between h, negative h, negative h, so we will end up with a sequence that is not conversion, h, negative h, h, negative h, h, negative h. We see that this sequence oscillates between a positive or a negative. It will never go to a finite number. Therefore, this sequence does not converge, meaning there is no solution using the Newton's method.